Yeah, subtract the other side over and then cancel. Oh no, I can't cancel. And I thought you said like
You make it equal 0.
yeah. Then you get closer to the quadratic.
Well, let's take a look at it right now. Take a look. It looks like we kind of have a common denominator, right? It looks like we have a least common denominator. Our goal, again, is to get the least common denominator and multiply through. Jared.
Multiply
Yeah.
the first one by -1.
Why, Jared?
This way you have positive z minus 3 in the denominator.
Yeah, so factor out a -1 out of here in the denominator. Take a look at this denominator here. Take a -1 out. It becomes -3 plus z. Everybody see that? Which is really just z minus 3. See the -1 that we factored out? Bump it up to the numerator. Doesn't matter. Okay? Again, make the problem easier for yourself. And I purposely use this problem. The next year we're going to do our word problems. So I wanted to come up with an equation that you can see pretty much everything that we're going to look at for this section. So if you don't have the denominator correctly, consider maybe flipping them around and just taking out a -1 and moving it up top. It'll always work that way if you need to. Okay? It could always happen if you need it. Now, what's the LCD at this point, Joe? Yeah. Z plus 3, z minus 3 is the LCD. Because clearly, if that's the LCD, everything is contained. Z plus 3 is there. Z minus 3 is there. Z plus 3, z minus 3 is right there. So let's make the LCD just that. What do we have to do? We have to multiply the entire equation by that LCD. Ian, help me out here. The whole equation needs to be multiplied by the LCD. Good. So here, as Ian is saying, oh, z minus 3, yeah. This z minus 3 here is going to cancel with this minus z minus 3 here, leaving a z plus 3 behind, right? And there's another z plus 3 over there also. So let's write that out. Yes.
You have to factor that.
We're going to have to in a minute, yeah? That's the first one. We're done. Second one. What's going to cancel on the second one, Chris? The whole denominator is going to go away because it's all right here. They're going to cancel. That cancels with that. Leaving behind
11 plus 3 over 1.
11z.
Okay.
11z plus 3 all over 1, which obviously doesn't matter. In the last part, right?
Z plus 3 cancels.
Yeah, z plus 3 is going to cancel here.
Do I have to, it's just 1 minus 5z in parentheses 2.
Very good. And then what?
Z minus 3.
Yeah. The 1 minus 5z, though, as Ryan noted, is a quantity. It needs to be in parentheses. Okay? And now what kind of an equation do we have, everybody? Yeah, it's a quadratic equation for sure. So this is why we have to multiply out to simplify. So it's going to be tedious.
Z squared plus 6z plus 9. Then the rest of it is z -3 or minus 3 negative minus 5 z squared minus 15 plus 15.
15z. Okay? So Ryan's clearly foiling this part, and I would do the same. I would not try and do that in your head. I would actually go through the FOIL steps because it's messy. On the left-hand side, distribute the -1. Just going to erase it.
Could you divide by it?
No, because there's not... Well, how would you divide by it? Explain that.
Like divide out of that side and put it to the other side.
No, because it's not in every term. It's not in it's not in the part with the 11z plus 3, right? So you have to have the whole thing multiplied by -1 for that to work. Okay? All right. At this point, what do we do?
Cancel. Or
Yeah, combine like terms. Good, Chris. Combine like terms. So we have negative 5z squared. Why don't we add that over here, right? To make it a positive for the z squared. I'd move them all over to the left in one step. You can do it on your head. Come on. Add the 5z squared over to both sides. This becomes 4z squared. On the left-hand side, how many z's do you have? Do it in your head, please. You have 5 on the left-hand side right now. Not yet. So we have negative 6z and the positive 11z gives me positive 5z. But then we have to subtract 15 from that. Negative 10. Then subtract another 1z. Negative 11. Finally, we have 9 as a negative and 3 as a positive, giving me negative 6. But then add this 3 over. Okay, and now I have to factor that. If you can't factor that, what do you do? Yes. Okay? If you cannot factor it, go to the quadratic formula. It does factor though.
What do you mean go to the quadratic formula?
Use the quadratic formula to find the roots. Everybody sees that, right? What else could it have been? It could have been 2z and 2z as well. So this is a messy problem to factor. That's why. Okay? Jared, did you get it? Oh, okay. What did you get again?
4z plus 1 and z minus 3.
Yeah. I would do what Jared said for sure. I would use AC method here. The minute the leading coefficient, A, is a quantity with factors that are not just 4 in itself, but 2 and 2 could work, it gets messy. I would use AC method. Or again, quadratic formula. What do we get as our answers, Jared?
Negative 1/4 and 3.
Well, what do we have to do right away, Jared?
3 does not work because it makes the equation.
Yes. The 3 automatically doesn't work because it makes the original undefined. Checking negative 1/4 does work. I'm not going to show the check today. I told you that. Okay, I want to get to the problems. Okay? That's our answer for this one. Now, had you used the quadratic formula, you wouldn't have gotten these factors here. You would have gone straight from this line to this line. Okay, that's what the quadratic formula would have done for you. Okay? Or the program on your calculator you can run it through if you're practicing.
I don't know how to use calculators.
It's an unfortunate thing, right? I mentioned that to the other class. I am including calculator participation as a grade.
Yes, I do.
Because nobody has their calculator. No one's ever prepared with it.
I have it.
I'm glad they're in your bags, but they should be on your desk as soon as you get in here. You should be going through these problems together, right? It's very rare when I say, give me a number or find the answer, choose me the same people that'll help me out. I want everyone to have it out. So this is not an individual thing to you personally. I'm saying in general. Okay? I like how you all took it out now. The last class I said, all right, let's go guys, calculate it. Everybody went like this. And they started writing it. I'm like, use your calculator. Like it was this crazy problem that there was no reason you would write it. And everybody started writing it. I said, take your calculator out. And then one person or two people had it in the whole class. You guys are better. You have it, but have it out when you come in. All right, let's take a look at the second problem. So, once, and don't worry, because by the end of the year, I'm going to teach you a way to do it without the program. You're not going to need the program. Okay? I think so. For this problem, we have an example where we're looking at two rates. And this is a very standard math problem. This is like, Ian, imagine if you were, let's say, do you have a backyard or do you live in an apartment? Apartment? What's a chore around the house that you have to do? You have no chores at all? Are you kidding me?
I'm kidding.
I don't want to hear about it. Do people have chores? Thank you, Chris. Chris, tell me, you guys stop. Chris, what do you have to do? Okay, clean dishes, exactly. When I grew up, I always had to clean the dishes. Now, Chris, if you clean the dishes by yourself, it might take you 20 minutes, right? But if your sister or brother or sibling, maybe you don't have one, but brother, only child, okay, your mom says, hey, Chris, I'm going to help you and I'm going to dry them. It takes you less time, right? Clearly, that's what's happening here. But the question becomes, how much time less does it take? Can we figure it out mathematically? And the answer is yes, we can. Okay? It depends. Depends on if one person works at a faster rate than the other, then it's not necessarily a half, right? It's some average number there.
They had an example problem of this in 5.8, like cranes.
I was so confused.
Was it one of your homework problems?
Yeah, it was, well, I was, because there were whole problems I wasn't sure of, so I was like flipping through this section, and they had a problem like this.
With cranes or crayons?
Cranes, like
Like a crane does this much work to lift
They do
something?
this much work, and then this is the fraction of work they each do.
It's going to be the same type of problem to solve yet. I thought we hadn't seen it yet as an example, that's why. But it might be in your homework or problem set. So for this problem, folks, we say we have one spray paint gun that can paint a wall in 4 hours less time than the other. Together they can paint the wall in 14 hours. Okay? How much time would it take the smaller spray paint gun to paint the wall alone? To paint the wall alone. I think that this would be a little bit different than the one you saw. A little bit different, the question, the way it's asked, but the same idea. Okay? So, we need let statements, right? Our let statements always answer the question being asked.
As the big spray gun with X.
Okay. So let X be the bigger spray paint gun.
The smaller spray gun uses X.
That's my fault.
What do you mean the bigger spray paint gun?
The bigger one equals X minus 4, the smaller equals X.
Okay, but what do you mean it equals the bigger one? The bigger
Like
one
how much
what?
time it takes.
Thank you. So make a statement.
But the time the bigger spray gun takes equals X.
Okay, so let X equal the number of hours.
Yes. The bigger spray gun takes. With the smaller spray, that X plus 4 equals the amount of hours the smaller gun takes.
Okay? So we have, in one scenario, that's an E at the end there, sorry. In one scenario for X, we say that that's the amount of time it takes for the larger gun. But the smaller gun takes 4 more hours. Takes 4 more hours. So we have to say X plus 4 because it's an additional 4 hours. An additional 4 hours. Now, the next part is tough. Okay, the next part is something that you might not see. This is what I want to go over now. So, what I want you to think about is, what does the fraction 1 over x represent now in this problem? What would that mean to you in terms of this?
One would be the amount of hours it takes, the bigger thing than this one.
It'd be like a rate, okay. Good, good. Keep going. What does x represent, Joe?
Over the mouse and the large gun to paint the wall.
So give me a number. How long does it take the larger gun to paint the wall? Pick a number, Joe. Any number.
69.
69 hours, okay. 1 over that. What does that mean?
That's 169 hours.
Yeah. So what does that mean, though?
It's a rate. How much will do in 1 hour?
The work that will be done in 1 hour. Exactly. The work that will be done in 1 hour. Try it again. Pick a number like 2 or 3 to make it easier on yourself. It takes 2 hours to paint the whole wall. So 1 over 2 is half the wall, right? That's how much work will be done in 1 hour. So 1 over x is the, write this down, the amount or the fraction of the wall painted by the large gun in 1 hour.
The fraction or amount?
The fraction of the wall painted by the large gun in 1 hour. Jared.
And then 2 over x and 3 over x would be
2 hours, and 3 hours, and 4 hours until you get up to,
14.
or however many hours it takes, right? 14 in this case, yeah, it couldn't be more than that.
That's 1 and 14 of X equals 1.
Yes, when you get to 14, it'd be 14 over 14, which means in 14 hours, they'd be done painting the wall in this case, yeah. But we have a combined one, so we have to think about both. Now, that's the larger gun. So the amount of the fraction of the wall that the smaller gun will do in 1 hour is 1 over what? X plus 4. Now, Chris, which Which is bigger, Chris? 1 over 6 or 1 over 10? I hope so, right? As the denominator goes up, the value of the fraction goes down. Like 1/2 is bigger than 1/4, which is bigger than 1/8, which is bigger than 1/16. They're getting smaller, right? So take a look at this number. Is this number going to be bigger or smaller than this number? Yeah, 1 over x plus 4 is definitely going to be bigger. It's definitely going to be bigger. The denominator here, the denominator is bigger, which makes it smaller. I just agreed with you, Joe. The denominator gets much larger. So this fraction as a whole gets smaller. Why is that number smaller than the other number? Realistically. Smaller gun does less work. There it is. Again, this is how much, or the fraction of the wall that would be painted by the smaller gun in 1 hour. So we have the fraction of the wall painted by the larger gun in 1 hour, the fraction of the wall painted by the smaller gun in 1 hour. So, what would that do for me? That tells me that if I want to know after 14 hours, this is how much of the wall will be painted after 14 hours. Okay? Again, if it takes the large gun 20 hours, after 1 hour, 1/20th of the wall will be done. After 14 hours, 14/20ths of the wall will be done. Okay? If it takes the smaller gun 35 hours, well, actually it says 4 more, right? So this is 20, this will be a 24. So if it takes the smaller gun 24 hours then to paint the wall, 1/24th of the wall will be done in an hour. But after 14 hours, 14/24ths of the wall will be done. How much of the wall is being done in this problem? All of it. Which as a fraction is what?
14 and 14.
Yeah. So we know that the fraction of the wall done by the larger gun plus the fraction of the wall completed by the smaller gun has to equal the whole wall being done. Okay? The whole wall being done. Yeah, that's why. That's what makes it tough. They're painting at the same time, so we can't look at them separately. We have to look at the fraction of the wall by the larger gun, the fraction of the wall by the smaller gun in 14 hours equals one wall being painted. Because it said the whole wall was painted in 14 hours. Joe?
Is it possible that you could have a smaller gun, which is more compact, could generate more pressure?
Yeah, for sure. By smaller, they mean like less power. Okay, but yeah, absolutely. 14 hours? I mean, yeah, I would agree. Maybe it's like a room instead of a wall, I would say, right? Can I put wall?
Maybe they're just in
Yeah, a
addition.
different wall. We're talking about the side of a building.
Alright.
It's a big wall. What's that?
They could just be in addition.
That also, yeah.
Maybe they're making designs.
Whatever. Now, what's the common denominator in this problem?
X plus 4.
Why?
Because it contains the x plus 4 and the 1.
Okay? Again, we want to get rid of our denominators. The only way to do that is to multiply through. What can x not be? Don't call it out. Raise your hand. What can x not be, Chris?
-4.
Or, good, Chris. -4 or 0. -4 would cause this denominator to be 0. 0 would cause this denominator to be 0, making the problem undefined. So let's multiply through by our LCD. Okay? X plus 4.
Why is it x plus 4?
The first denominator is x. The second one is a quantity x plus 4. We need both of those to be gone. So how do you get rid of an x? Only if you're going to multiply by an x, right? How do you get rid of an x plus 4? Only by multiplying by x plus 4.
X, and 4.
No. These are not x and 4, not factors. They are. The whole thing is a binomial. X and 4 in this part right here. X and 4 are what?
One denominator.
What's the word for them though?
Coefficient. Conjugate.
Thank you. What is it?
Add.
Addends. The quantity x plus 4 is a factor in itself. Because really, Ryan, look, it's really a 1 outside there. See that? That's why x plus 4 itself is a factor. So you have 2 factors, okay? There's really 1's there. Don't forget those. Anyhow, multiplying through. In the first term, this x cancels with this x, leaving behind 14, quantity x plus 4. In the second part, x plus 4 here cancels with x plus 4 here, leaving behind x and a 14. And at the end, nothing cancels, leaving the whole part behind. What kind of an equation is this, folks? Quadratic in nature. Very good.
Yeah, do we now know?
Actually, I think you can have it.
What should we do? Distribute.
14x plus 56 equals 14x equals x squared plus 4x equals 28.
Okay. Now, here's what we're going to do. Yeah.
You can't divide 14 by x plus 4 because it's plus 14x. Is that why you can't do that?
Well, the problem is that you could divide the left side of the equation all by 14 to get rid of it, but then you have to divide
x
the...
plus 4. Divide each side by x plus 4.
Divide each side by x plus 4? No, because the 14x.
Yeah.
Correct. Yep, Jared. Very good. That, if you did that, Jared, that would bring you back to a fractional equation, wouldn't it? Which is kind of defeating the purpose there. But you could try it, and you would see that. Move the 14x's over by making them 28x. Joe, what's wrong? Make these 28x together, and you have a 56 still. And then move the 28x over. And move the 56 over. Can this be factored?
Possibly.
Possibly. What are the factors of 56? Go.
7, 8.
Doesn't work. Go.
28.
Good. Doesn't work. Go.
18.67.
1 and 56. Doesn't work. Go.
56 and 6.92.
How about 14 and 4? No, that doesn't work either.
Can't we just
Not
put it in?
factorable quadratic formula.
Good. So we need to use our quadratic formula here. If you do that,
Negative b plus or minus.
no, we're just going through answers. We're not even. You guys got to do that on your own at this point.
56.
Wow.
So x represents what in this problem, people?
Large number of hours.
Number of hours. Can there be a negative number of hours, Chris? So the number of hours it takes, the larger gun, is this number. But what did we want? The number of hours it takes the...
Smaller.
So what should we do to that number?
Put it over x.
Add 4. Because it takes the smaller gun 4 more hours. So your answer is actually this right here. It takes the small gun 30.1 hours if you wanted to paint the wall alone.
It's funny, remember you said once the small gun took 30 hours? Foreshadowing the answer?
Who would have thought?
You.
Probably. Alright. Next and last problem.
Next to last or last?
Next and last problem.
Oh, there's only 3 examples.
Say again?
There's only 3 examples.
Yeah, we're just doing 3 examples. Your book is an example of a problem like this. I solved it a different way. You can use the book, but I would recommend my way. I think it's easier. But feel free to read the book tonight to see another interpretation. Okay? So again, there's a different solution for this kind of a problem. It's example 2 or 3 in the notes in the book. Different numbers and stuff, obviously, but they use a different method. I'm going to use something else. So a boat travels up and down a river. And? What was it? And? Should be A. Up and down a river, a total distance of 80 kilometers. Due to the current, the speed upstream is only 30 kilometers per hour. What must it be on the way downstream in order for it to have an average of 35 kilometers per hour for the entire trip? Okay, for the entire trip. What kind of a problem is this? Distance rate. So what should you start with right away? Yep. Okay, that needs to stay in mind. Now, the whole trip is 80 kilometers, so what's each trip leg?
With a little 40.
Okay, the total D is 80, right? What do we know so far? What else do we know? Givens, what else?
Your upstream is only 30 kilometers per hour, so your downstream has to be at 40 kilometers per hour. Right?
Well, we know that it's got to be something bigger than 35 for sure, but it's not going to be 40. I can tell you that right now. Because think about it, Joe. If you travel faster or slower, Joe, listen. If you travel, it's not, trust me. If you travel faster or slower, you spend more time on the river at that rate. So it's not evenly distributed. So if I travel really slow down the river, I spend a lot of time at a slow rate. So I need to compensate by going at a much faster rate for that shorter period of time to have an average of 35. It is not 40. But this is always a multiple choice, and it is not 40. This is like an SAT multiple choice always.
That makes sense, that makes sense.
Okay, and they put 40 as the answer choice because they think they just average it.
Why is 40 the answer choice twice?
It's not. It's the distance, each leg of the trip.
Yeah, why is it distance twice?
It's 80 total.
Oh,
Read the
okay.
right. Read the beginning.
Yeah, no, I read that. I just got confused.
It's all right. So we want the average rate to be 35. The common mistake is to say that R2 is 40. It is not. Again, it is not. It is never going to be. Don't fall for that mistake. Now, the time it takes, we don't know for either of these. Let's see what we have here. If we solve for t, everybody see that? Let's look at the three scenarios, people. Let's look at all three scenarios on the way up, on the way down, and the overall trip. Okay, and do this 3 times. Because, tell me if this does make sense to you. Right? The total time is equal to the time it takes on the way upstream plus the time it takes on the way downstream. So if we can somehow come up with expressions for all 3 of these t's, we can plug them in there and then have an equation. So let's do this. Let's take a look at this formula, t equals d over r, and plug in 3 times. On the way up, how much distance do you travel?
40.
What's the rate on the way up?
30.
So that's t1. Again, on the way upstream, it's 40 miles or kilometers at a rate of 30 kilometers per hour. So that's t1. That's going to go in for t1 up here in a minute. t2.
40.
The distance traveled is?
40.
It's still 40, because you're going 40 kilometers on the way back down. But Ian, do we know what the rate is on the way back down? That's our question mark. So let's just call that R2 for now. That's going to go in for T2 up at the top. So far we only have one variable, because T1 and T2 are going to be replaced. We have 40 over 30 and 40 over R2. So R2 looks like what we're solving for. And take a look. What must its speed be on the way downstream? So that's what we're looking for, R2. What's the overall trip? Overall trip is 80 kilometers. What's the speed for the overall trip supposed to be?
30 plus x.
You're told, it's a number.
Oh.
35. Look, we want the average speed for the entire trip to be 35, right? So that's just 35. Okay? So take a look. These 3 fractions are going to go in place of this equation at the top that's boxed in, yielding an equation with only the unknown of R2. I'm going to simplify, by the way. What's 80 over 35 in simplest form? Quick.
2.28.
Come on. Simplest form, not decimal form. People, they're both multiples of 5. This is 7. This is 16. Like, see this? They both end in 0 or 5. Divide them both by 5. Come on, you got to be quicker than that. You don't need your calculator for that either. 80 divided by 5 is easy.
I was doing 80 divided by...
I'm just saying. Now, what's your LCD in this problem?
41 r squared, 3 times 7
21 for sure, because 3 by 7, and the R2 is another factor. Okay? R2 is a variable. It's not R squared. It's not R squared. R2 itself is a variable. So multiply by 21 R2, the entire equation. In the first part, the 21 and the 3 are reduced to 7. And then you have 7 times 4, so it's 28 R2. In the second part, the R2's cancel. And you have 21 times 40, which is going to give you 840. In the third part, 21 over 7 becomes 3. 3 times 16 is 48. And that's going to be R2. Again, cancel, make that a 3 times 16 is 48. Cancel, make that a 7 times 4 is 28. Cancel the R2's, 21 times 40 is 840. At this point in time, collect your terms, please. Move it over. All right? What do you get? So, Joe, do you believe me now?
Yeah, well.
Not that you didn't before, but now it makes more sense. The rate, and here's what I want to do. We're going to act this out real quick. We've got 1 more minute. 2 people come up. Very easy. 2 people. Brian, come on up. Joe, thank you. Come on up. All right. So, if Ryan walked faster than Joe to the wall, Ryan walked a little bit faster than Joe. Okay. When Ryan gets to the wall, stop, both of you. Stop. So, it takes Ryan what? 3 or 4 minutes to get to the wall? How long will it take? 3 or 4 seconds to get to the wall? How long will it take Joe? 5 or 6, 6 or 7, some number greater, right? So, when you walk slower, you're on that path for more time, right? So on the way down on the trip, they go very slow. So they're on that path for a long time. But on the way up, they go faster, don't they? So they're only on that part of the trip for a short period of time. So for it to work, the original number we had was 30 on the way down. And we wanted an average of 35. So since Ryan is going faster in this problem, it's going to take him less time to go upstream. So it can't be 40. Because he's going to be on that part of the group or that part of the trip for less time. So the average is not equal. It needs to be like a weighted average. So he needs to go a little bit faster to make this average to be 35. Because he's on that part of the trip for less time. He's only on that leg of the trip real quick. If you try this with a 40 here, you're going to spend less time on that leg of a trip, and the average speed would only be like 34. Okay, it'd be a little bit less. So because he's spending less time on that part of the trip, he needs to go a little bit faster than what you might expect. The answer would be a 40, it's 42. A little bit faster. Okay? Thanks, guys. Yeah?
Isn't the average about 36?
Isn't the average what?
36.
No, because remember he's on that part of the trip for a longer time. If you were to do an average, watch. If you had 2 tests, or if you had a test and a homework, can you just average those together and get your grade? What do you have to do? You have to multiply by a weight, right? The percentage of the category. Oh, the time on the trip is the weight. The time it takes. Okay, it's like the weighting.
How do you insert the arrows?
Oh, yeah,
Sure.
can I have
That's
the back?